the screen share going here. All right. Everybody see the screen all right? Okay. Well, welcome everyone to day 4, and it's been quite an event so far. Glad you could make it this far into what's normally a 3-day event. So my talk here is, as Dave has said, Accelerate Quality, Validating Your FHIR Implementation Guide. We're going to start here. Let's see. Oh, yeah. So let me first just give you a little bit about my background. I'm the lead architect of the Touchstone testing tool from aegis.net. Been doing this for quite a while. Been in the industry for a while, most notably the last number of years in health IT and the last 6+ years contributing to the FHIR spec with a focus on testing. What we're going to be looking at in this session is obviously FHIR implementation guides, but we want to focus on how validation is built into those implementation guides and how we can leverage what's built in. I have a couple of demos here that I'm going to be doing, so I'm somewhat brave in that fashion. The first one is actually going to be demonstrating the publication tooling, and then after that's done, we can take a short break for some questions. And then I want to get into the aspects of testing and certification support within the IG. We're going to walk through a scenario within an IG that I'm familiar with and how we can take that scenario and move it into a test definition or test script. And then finally, I'm going to end with, or I'm going to go through a demo using the Touchstone platform with those test scripts and show you how we can execute those. Then a few closing remarks after that, and then we'll be good to go. Again, any questions that come up along the way, just put them in the session Q&A, and I'll be pausing at the end of each demo for questions, and at the very end as well. So let's go ahead and get into FHIR implementation guides. So for those that are familiar, this is probably a review, but for those that are somewhat new to implementation guides, within the FHIR specification, there's this thing called an implementation guide. It's an actual resource type, but it defines a set of rules about how FHIR resources are to be used or should be used in a particular scenario or problem space. Along with the implementation guide, when you go publish it, you produce the associated documentation that supports and clarifies this usage. So if we think about it, the contents are a set of logical statements that represent what those conformance requirements are that implementations must follow. And importantly, there's a lot of other artifacts that come along for the ride. One of those are things like examples, which are included that show the intent of those profiles. From a validation perspective, it's built into the IG. So when we go to think about testing, validation testing for conformance to the IG, that's going to involve things like verifying the proper behavior based on the IG narrative. So the narrative is that documentation, the guidelines, the use cases, and the scenarios, as well as security requirements or anything else that needs to be read carefully. So that's why I want to point that out. Read the IG carefully. Don't just look at the profiles and so forth. The use cases and that documentation is critical to understanding the intent of the IG. Along with it, though, is the use of these conformance artifacts. And these are the conformance resources built into the FHIR specification. Those are our FHIR profiles, and I'll get into that in a little bit more detail, but they feed into a FHIR validation engine, which is used to verify the resource instance content. So in the community, we've got a couple instances readily available to us. Within the FHIR specification, we have the Java reference implementation, or the core libraries, which contain the validation engine, and that's actually published as a jar file that you can download. Graham Grieve, James Agnew, as well as many members of the FHIR community maintain this. There's also a .NET flavor of the validation engine available as NuGet packages for download and inclusion in your applications, or as a standalone, if you will. Eva Kramer, Brian Postwaite, as well as many other members of the FHIR community help maintain this as well. So let's take a look at narrative. As I said, the narrative within the IG are the descriptions of guidelines, use cases, scenarios, security requirements, all of that dialogue in the IG that helps us to understand what are we supposed to do with this, how are we supposed to implement. But we take that information and we can also glean from that how we define testing, so those test definitions or test scripts. So these are everywhere from simple tests for individual operations, request response at an individual level, complex tests with multiple operations and even multiple actors simulating workflow patterns. In the test script itself, we have assertions, and those assertions are the actual rules that will be implemented and executed and evaluated to verify the conformance of the resources of the operations to the FHIR spec as well as the constraints within the IG. And then also asserts to verify specific requirements. So that narrative will also feed into the assert. So we have to make sure that we conform to all aspects of the IG. It's important to understand and realize that I'm mentioning TestScript, that's an actual FHIR resource type. So you can go to the FHIR specification and go take a look at that. It's rather large in scope, but as you can imagine, it's there to define a test definition, an executable test definition. Within the FHIR specification is also the definition of a testing framework. And so there's a testing.html page. And one of the key aspects of the framework is that it actually defines a FHIR test engine, something that will execute the test script and evaluate and report back outcomes. So that's a very key element here as well, too. Of course, beyond the narrative content, we have our conformance artifacts, and these are the conformance resource types that basically are the true definition of the constraints and the things that we need to build and so forth. We think of these things, the profiles, the structure definitions, which are the data structures for extensions that we put onto existing resources, cardinality, where we can constrain even further the min and max values or number of elements, constraints or invariants, which are those FHIR path expressions, terminology bindings, and so forth. If we have any custom operations that follow the FHIR specification operations framework, that's our operation definition. So that provides us with other pieces of functionality that the implementation guide may require in our servers and clients to support. Search parameters as well. So the FHIR specification provides a lot of base predefined search parameters, but we may decide we need to be able to search on other elements within resources. So again, another resource type called search parameter. From a terminology perspective, if we're going to be defining new value sets or new code systems, those are primarily the things that we think of when we get into terminology, but there are many other terminology resources as well that we could leverage. But primarily when I think terminology, from my perspective, it's those value sets and code systems. So all of that information, especially the conformance resources, are the things that we're going to leverage when we start to validate a resource. So this is the data, the resource data, that conforms to, or we say conforms to, what the IG is defining. So if we want to validate that resource, we have to leverage the FHIR profiles and all those other resources potentially to validate. And what that means is we look at the structure of the resource in question. So we want to check to make sure that all the content in that resource is described as is in the specification. We don't have anything extra present that we don't understand, and so on. Cardinality, as I said, we want to make sure that elements have the correct number. So we have at least the minimum and we have no more than the maximum. Value domains, things like our data type checking. So an element has a data type assigned to it. Well, there are rules for what are the allowed values. So we need to follow those as well, whether those be primitive or complex data types. Code bindings. So if I have an element that is of type code, coding, or codable concept, those are the things where we have those value sets that are bound to that element. So part of the checking is to make sure if I have a code value and it's display for that value, that it's within the correct code system as defined by that value set. Invariants, again, use of FHIR path expressions. And so that's the language that is used to provide those additional constraints where we can do checking between elements and values, make sure something is present if something else is, and so on. Again, we need a FHIR validation engine to implement this. And again, we can leverage the existing Java reference implementation or .NET as well. What's also important is in our FHIR testing framework, the FHIR test engine also needs to be able to support this. So the FHIR test engine needs to be able to leverage the validation engine as well, too. So a lot of stuff is built into the implementation guide, but the implementation guide itself needs to be published in order for someone to actually work with it and implement it. So part of the process here is, especially if you're authoring an implementation guide, you need to be familiar with where are you going to publish this. If you're going to be using it, you also need to know where it's going to be published. So there's a few tools right now that are available for this. Simplifier.net from FHIR. They provide a registry for implementation guides. We have a couple examples here, like Canadian e-referral. The NICTIS MedMy program uses Simplifier for the registry of all its conformance artifacts, but it maintains a separate wiki site for its publication, for its narrative, if you will. There's the FHIR publication tool, or IG publisher, from the FHIR specification. You can go to the HL7 Confluence site to find out more information about how to download and actually run this in your own local environment. Some examples here are things that are part of the HL7 registry of implementation guides. Immunization forecast, which is what I'm going to be looking at in just a little bit, and Davinci, because that program has many use cases, each with its own implementation guide, the US core, and so on and so forth. So go to the HL7 FHIR registry to take a look and see what's been published so far. Another tool that has come in relatively new, still under some development, is Trifolia from Lantana, one of our sponsors. This is a Microsoft C#.NET based tooling. To find out more information about Trifolia, you can go to their site and take a look at that. So let's take a look at a couple examples of what an implementation guide looks like when it's published. So if we were to look at, say, the NICTIS MedMy program's implementation guide, as I said, they use Simplifier.net to store all of their conformance resources and so forth. So you can go to Simplifier and you can actually download their validation package, a collection of all the resources from the publication process. But the narrative is stored or is maintained as a separate website or wiki site. So you can go there and take a look at all the narrative content. But if you want the actual conformance resources, you would go to simplifier.net. If you're using the HL7 FHIR specifications IG publisher tool, well, here you're going to build a framework of files and resources that are going to feed into this tool that will eventually come out with a website very similar in look and appearance to the FHIR specification itself. So here's an example of that immunization forecast IG that I mentioned, and it's still in a ballot status, so it's not an official 1.0 version yet, but it's still in work, but it is published so that people can actually start to look and use it. So we can go take a look at that as well. So I'm going to actually get ourselves to our first demo here. So I'm actually going to use the IG Publisher tool, and I'm going to take the immunization forecast IG from the GitHub location. So I've checked out from GitHub the IG contents here, all of the files and so forth. And I'm going to run through the IG Publisher tool just to give you a brief demonstration here of what you would do in your local environment. And the focus of this is to actually look at that validation package that we want to download and eventually use in our validation testing. So I'm going to flip over here to the command line that I've already started, and this is just a Java jar running the Publisher tool. And this has actually a nice GUI interface to it. You can run it just through the command line if you wish, but I like to use the GUI interface. So the idea here is that you're going to choose from your immunization FHIR DS GitHub repository that I've checked out, the ig.json configuration file. So the IG publisher uses that as essentially how it's going to start working through all the different components and putting it all together. Just click execute once you've got that selected, and off you go. And you can see in the background here, it's doing some things. So if I have an outdated version of, say, the FHIR core library or the FHIR specification package, in this case, FHIR R4 version 401, the latest official, you'll notice it had to go out and do a fetch, and now it's installing it in my local cache. Once it's completed that process, then it can start working on the rest of what it needs to do. So I can see all the details of everything it's working on as it starts to go through. Back on the main interface, I see more of a summary roll-up of what it's doing. Eventually, what it will do is generate all of the HTML output based on the markdown, based on HTML snippets, as well as the conformance artifacts that I have in there. And that's going to be put to an output folder that I'll be able to access once it's done. It uses the Ruby Jekyll gem to do the processing of the HTML, so we've reached that point in the process. And it gives you nice timing here as well too. So it's taken about a minute to get through all of this stuff. And this is actually a relatively simple, not an extensive IG. But when it's done, you'll notice I've got an output here. So I've actually got a couple errors, some warnings, and a few info messages that I may need to look at. So as an IG author, I would want to go through and then examine, well, what went wrong or what do I have to look at? So the tooling here actually has some links to some of the pieces from the output that has been just produced. The View QA here actually brings up in a browser, and let me make this a little bit bigger for you so you can see it. So this is the QA page from the IG publisher, and it gives you some general information about what version of the IG publisher was used, but then an overall view of what were the errors and what were the artifacts where I saw some issues. So it looks like I've got something here with a couple of my profiles, and I can click on this and drill down into that, and I can see, the structure definition has something wrong with the jurisdiction. That's one of the metadata elements in structure definition. If I scroll down a little bit further, this is an enhancement recently. Graham has added a nice summary of all the different errors and messages that come up. So I can see jurisdiction seems to be my main problem here. And then it looks like I have a bunch of informational messages based on code systems for codes that might not be valid. So I'll probably have to go in and update those, or at least inform the author of some of these issues so they can be corrected. Another aspect of this, if I go back to the GUI interface, I can actually view the IG itself that was generated. So this is a link to the index page in the output folder, which is exactly what you would see when this gets published out into the HL7 registry. So here is my local file system output folder of that immunization decision support forecast implementation guide. Nice long name there. But as you see, this is one that I'm familiar with because I've actually been a contributor to this one. And we can look at the profiles and extensions, we can look at operations, we can look at terminology, all of these things that feed into the definition. But as I said, the narrative is pretty important. And so we might want to go to the guidance page and look at some of the background, the purpose for this, and most importantly, probably the use cases. What's the use case behind this particular IG? So we'll take a look at this in a little bit more detail coming up. So at this point, though, I would like to just do a quick pause to see if there are any questions that have come up. So I don't think I see anything in the session Q&A just yet. So if we're good, I'm going to continue on. So now that we have our IG published, one of the aspects of this, as I said, is the validation package downloads. That's going to feed into the validation engine. But most importantly, we want to look at the whole of the IG in terms of how we're going to perform our testing. So moving on here, testing and certification support within the IG. We publish the IG, and that can again be to a local or public website. could be a specialized wiki, PDF documents, whatever it might be. But what's important is that we have that human readable information, the narrative, formatted text, pictures, attachments, and so forth. And we look at that narrative to get an explanation of how to implement those specific use cases. Again, read carefully to understand what the requirements are, not just from a technical perspective, but from a business perspective as well, too. The conformance artifacts are then packaged for us for use within the validation of data contents. So let's walk through an example here. From scenario to TestScript or test definition. We're going to take a look at some key points within that implementation guide that was just built and try to understand what it is that we need to test. Understanding, of course, that someone's going to be implementing this, and then we're going to be providing support to test that implementation. So first, if we look in the introduction narrative, we can see why we're doing this. What's the purpose of this particular implementation guide? So we can see there's a couple actors here that I've highlighted. We have a system seeking a patient evaluated history and forecast. Remember, this is immunization data. That's going to be our client requesting the data, and then a clinical decision support engine with a FHIR operation in it. So it's going to be a FHIR server with a support engine behind it that's capable of providing that history and forecast. The scope of this implementation guide is to create that standard interface layer using FHIR between that initiating system and the CDS engine sitting behind a FHIR server. When we look at the use case, as I was scrolling through, you probably saw we have pictures and diagrams and all kinds of good things. So this just helps, again, to get us leveled set on what is the focus here. So within our environment, we have like a immunization information system, IIS, and that could be built into an EHR system or some standalone tooling. But the focus is not on that tooling, but on the interface between that request to the CDS engine, the FHIR interface to the CDS engine. And so this green section here is what's in scope for the IG. Request the information and get it back using FHIR. The implementation details are there in the operation definition. So this is an example where we have an operation definition following the FHIR specifications operation framework. Now we know that it follows the operations framework from the FHIR spec, so we can take our clue as to what we're going to be testing from the FHIR spec itself in this regard. We know that the client in this case, or let's say we have a test engine acting as a client, needs to be able to send the request message properly formatted using the appropriate operation here, which is IMM-DS-forecast. The parameters is going to be the payload. So we have input parameters and we have output parameters. Some of them required, some of them optional. And so that information helps inform us as well, too, as to what we could do for testing purposes. So we could see that we might have some things that are required. What would happen if I didn't send something that was required, or I sent something that was incorrectly formatted, or if I set something that was correctly formatted, do I get back things as I expect them? So as we start to examine the ways we might be able to test this particular operation, we have to think about that. So let's kind of tease that apart a little bit and think about our test definition. So our test script, our test definition, we're probably going to end up with more than just one test script. We're going to probably end up with a couple or more. But the idea is, well, first and foremost, we want to do positive testing. We want to be able to send good data in, and we want to be able to get good data back. So the expected outcome of a success would be a 200 response code with a parameters payload that conforms to our specification and contains all the data that I expected. Conversely, we need to also check to make sure that our system under test, in this case the CDS engine, is going to be able to handle when I send bad data. So negative testing is pretty critical here as well too, because I don't want, what if something were to go wrong in the process? I want the system under test to be able to respond appropriately so that I as a client know how to deal with that information, how to deal with that failure. So again, we're following the operations framework from the FHIR spec so that we know that if there's a failure in that operation, we should get back an error code, a response code of a 400 or 500, and we're probably going to get an operation outcome back in that response that tells us what went wrong. Additionally, you want to make sure that all the required optional response HTTP headers are there. Again, we can invoke the validation engine to make sure that the payloads conform to the spec as we would expect. So that leads me into my next demo. And this is where I'm going to be leveraging the Touchstone testing platform. So this is a publicly available cloud-based testing platform for FHIR. We can test both client and servers with this. We're going to focus on server-only testing in this particular case. But the idea here is we want to take our implementation guide and focus on that happy path and that negative testing that we just described. So I'm going to go out to my browser now. And I'm first going to show you the public site. So this is the Touchstone landing page for the public site. So if you go to touchstone.com, it'll redirect you to the actual site. And if you click on the Touchstone logo in the upper left corner, you're going to come to the landing page here. So one of the things that we're working on with Touchstone right now, and you might notice that in the coming soon section, is that we've got some enhanced support for validation processing. So I actually want to show that off a little bit, but we don't have it deployed in production yet. So I'm going to give you a sneak preview here of what we have in our QA environment. So this is internal here to us, and I'm going to run those test scripts that I just described, both happy path and negative testing, and we're going to take a look at how we can play with the validation engine a little bit to see how we can also customize what we're doing. So I'm going to sign in. And once you're signed in, you have access to the test definitions. So over on the left-hand navigation in Touchstone, we have a tree structure here where we have all of the folders that contain all of the test scripts that we're hosting. So you'll see we've done a lot of test scripts that we've already built for different versions of FHIR, for connectathons. We have some basic and advanced tests and so forth. But what I'd like to do is show you this thing we call the FHIR Sandbox. So you as an organization registered in Touchstone could have the possibility of uploading your own test scripts. So you may want to start authoring your own test scripts and putting them up where you can access them. Now I've done that here under our Aegis Sandbox folder. So that's Aegis is our organization name. And I have this FHIR 401 DevDays 20 folder. And I've got a few other things here besides what I'm going to demo, but I'm going to focus on the IMM-DS forecast suite of tests. So if I click on this, it'll refresh and show me, here are the test scripts that I have right now. Now, I've got 4 listed here, but really I have 2 because 2 are copies of the other. Just the variation here is what format of the payload. So basically, is it FHIR JSON or is it FHIR XML? And that's just, for demonstration purposes, so we can delineate between the 2. The test script itself, you can click on, and we can actually see the content. So this is, as I said, a test script resource type in the FHIR specification. I scroll down, and I can actually see we have things like fixtures, which is test data that we're going to be sending in. We have profiles. So here I have a parameters profile. So I can invoke the validation engine using the parameters profile. Depending upon what the payload looks like, remember, I could indicate within the data itself that the meta profile says that this data conforms to a particular profile. And so the validation engine will recognize that and actually perform specific profile validation if that's present. So we have an operation, a number of asserts, another test, and so on. So basically the nice thing here is you can see exactly what's going to be executed just by simply clicking and looking at that test script content. So this is my OK version. What we're going to do is test a FHIR server that implements the IMM-DS forecast operation, and pretty much what I had described in the slide here. We're going to assert tests that all required and optional response HTTP headers are present, and validate the return payload. So we are going to invoke the validation engine. Now, one of the enhancements that I wanted to show you is, well, which validation engine? So one of the new things that we're introducing here is the concept of when I create a test setup, which is one of the precursors to execution, now I can choose which validator or validation engine I want to use for this version of the spec. The 401 here is the base validator, so I've got the base specification loaded and maybe a few other IGs. But I also have another one that I'm playing with for one of our internal test companies or organizations called Initech. And this one is where I've actually uploaded the IMS-DS forecast validation package. So if I were to run this test using just the base package in the validation engine, I might see something a little different than if I use the other one. So let's go ahead and execute this. I'm going to do it against my Wildfire test server where I have implemented IMS-DS-forecast. So we'll do an execute, and we go to our execution dashboard. I'll do a refresh here, and I can see that we've already completed the two tests, the two operations, along with all the assertions. It's just a simple drill down now into the TestScript execution to look at the details. So it does say 100% success, but it is a pass W, so that's a pass with warning. So I do want to expand, and then this is a nice example of how we've collapsed everything so you can drill down to specifically what you're interested in. And what I'm interested in is this one little assert that invokes the validation engine. So it's going to take the payload of the response from my server, and it's going to feed that into the validation engine using the profile that I had indicated, that parameters profile. But remember, the contents may also indicate that it is supposed to validate based on another structure definition. In this case, the IMM-DS-patient profile from the implementation guide. But you'll notice I'm getting a warning here. It is could not be resolved. Well, that's because that profile is not loaded, or its validation package is not loaded in that validation engine that I just used. So we may want to go back and re-execute this using a different validation engine. So I'll go to test setup, and let's use the Initech version of the validator now. Still FHIR version 401, and no other things I need to select other than my destination server, and I'll execute it. So everything is pretty much the same, except, and again, pass with some warnings. Let's see what the difference is now. If I come down below, I can see my validation looks a little different. So instead of a warning message, I have a number of errors. So it is now correctly taken the IMS-DS patient profile, it found it in that validation engine and applied it to my data. And so it's saying, oh, I have a cardinality problem. Minimum required 1, but I only found 0 of what? Well, it looks like the parameter 0 resource contained identifier system was missing. So the contained resource within that parameter is supposed to have an identifier with a system defined, and it wasn't present. So this is giving you some very nice specific feedback on what you need to start looking at. So the reason I got a warning here is because the actual assert had warning only true turned on. So in the asserts that we define, we can define whether or not I want to just throw warnings regardless of the errors, or if I want this to actually fail should errors come back. So that's a nice example of how we can, in the very near future, with our next release of Touchstone, be able to provide support for different validation packages. And if you can imagine, I could have actually different versions of validation packages for different IGs available for you to test with. As an example of that, the new interface here is called IG validation packages. So if you have the rights to take a look at this stuff, you can see here is the 401 base validator. And you can see I've got a lot of IGs already loaded here, most of them Davinci, because we are supporting the Davinci program. But no, the immunization forecast is not present. If I look at my Initech, there's my immunization forecast. We can actually drill down into that, and we can see, oh yeah, there is my structure definition, IMMDS patient. That's why it worked that time. So this is just a brief preview of a new feature coming up in Touchstone 5. So it looks like I'm running a little close to time right now, so I would like to jump back to the slides just so I can get through them in good order. And hopefully, just to kind of wrap up here a little bit, so with Touchstone, we have a lot of support for testing and certification, but also at a program level. I've mentioned we do support the Davinci program, so let's just go there. We've been supporting Davinci for probably almost 2 years now, and so we are leading the development of TestScripts for various Davinci implementation guides. To date, there are about 20 active use cases in the Davinci program. I think there's 4 in the planning stage right now. And there's a number of reference implementations available for testing with Davinci. So from MITRE, within the Logica Sandbox, and even our own WildFire server. The different use cases, as you can see, I've taken some screenshots from Touchstone where we've deployed TestScripts within that folder structure under Davinci. So data exchange for quality measures to pair data exchange and alerts and notifications. So we've got a lot of coverage for various use cases right now. I do want to also promote a white paper that we authored about a year or so ago in collaboration with the MITRE Corporation and the Office of the National Coordinator. So a shout out to Jason and Rob and Connor from MITRE, as well as Steve Posnack from the ONC. And our own Mario Highland and myself collaborated on this effort. So please go take a look. As I mentioned, we have some example test scripts for you to play with within Touchstone. So I would encourage you, if you want to learn more about it and play around with test scripts, to go ahead and take a look. And here's where you can learn more about Touchstone if you are interested. So that leaves me about 2 minutes according to the clock, I think. Let me refresh my session Q&A, see if there's anything there.
No questions so far.
Okay, well, that would be all that I have to offer at this point, unless somebody has something they would like to ask.
I see no questions. To get a package into Touchstone, you need to actually download it. You cannot just refer it from where the registry is?
Correct, yeah. Yes, the mechanism that we've implemented is, so if you go to your IG, you can go to the downloads, and you would download that package and save it. The default name is package.tgz. You need to rename that because the name of the package file itself is going to be used in the upload process. So when I come over here and take a look at the packages that have been uploaded, I renamed it to this FHIR 401 IMSDS forecast. But when I upload, I'm really just going to browse for and look for that particular package somewhere on my file system, and then that will upload into that particular validator.
Perfect, thank you.
Mm-hmm.
I think we are on time.
Yep, I think so. I think that was pretty close. Any other comments or questions at this point?
The slides will be shared tomorrow. The other question is, can this process be integrated into the implementation of a FHIR server for IG? Well, so from an integration perspective, let me go back because I kind of glossed over it real quick. One of the things that we do have to support this is a RESTful API with Touchstone. So you can actually remote launch and monitor test executions from your own environment. The whole purpose of that was to support the integration with continuous build environments like a Jenkins or a Travis. We have different subscription levels to the tooling, which provide different features and so forth. But you know, in terms of integration support, the Touchstone RESTful API is how we would do that. Sorry, here we go.
Okay, anything else?
The last question is, for using Touchstone, do we have to create and provide the narrative and conformance artifacts plus the actual data to test, or Touchstone just need the testing data? You need both, I think.
So yeah, Touchstone is a tool, a platform for executing test scripts. So you need to create the test scripts or engage with us to help you in that fashion. The data itself is really whatever data you want. So the fixtures, as I mentioned before, would be that test data. So you would define your test data. You can then use that data to set up a server with it, or you could pre-set up outside of the testing tool and then just simply use it as you will. But typically, the IG itself will have a lot of example data that we can leverage and start to use for testing purposes. But again, Touchstone is a tool, and it's going to be acting as a client in and of itself when it sends messages, or we can act as a man in the middle with a proxy to do client-side testing, so we can actually introspect the request message as well as the response message in a peer-to-peer fashion.
We have no more questions.
Okay. All right. Well, with that, thank you for attending, and enjoy the rest of your last day of DevDays.
Thanks, Richard. Thanks, Diego.